Hello and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going through chapter 11.4, which is about the binomial distribution. So let's jump right in. So if we have a variable that, it's not a variable, like more of an event that can result in two possibilities, either success or failure, then we can map this as a binomial distribution. This is only if there. So in order to map something as a binomial distribution, four conditions need to be met. So first of all, the discrete variable is the number of successes in n trials, where n is a fixed number of trials. Each trial only has two possibilities, success or failure. The trials are independent, so one does not affect the outcomes of the other. And for each trial, the probability of success, which is p, is constant. Excuse me. And so this allows us to ask questions like, well, that we'll get to later. But we need to know a few more things about the binomial distribution first. So if a discrete variable follows a binomial distribution, then the probability distribution function looks like px is equal to x is equal to, x equals k actually. So k is the number of successes, is equal to n choose k of p to the k times 1 minus p to the n minus k, where of course 0 is less than or equal to p is less than or equal to 1. So this allows us to calculate the probability, and yeah, so for the mean and variance, there's actually a few very helpful things. So the mean of any binomial will be actually equal to the number of trials times the probability for each trial. And the variance will be equal to the mean times 1 minus p. This is actually very interesting that the sum of the squares is equal to 1 minus p. It's not, the sum of the squares is not equal to 1 minus p. This is because it's np minus np squared. Yeah. So, actually that's not the full method, but just yeah. We need to know that for a binomial, the variance is equal to the mean times 1 minus the probability. Okay, that being said, with all of that being said, let's jump into some questions. So, given x is a binomial, and this is the notation we use to say it's a binomial, this squiggly line, with 8 and 0.25, which means that there are 8 trials and there's a 0.25 chance of success each time. First, we need to find the probability that x is equal to 3, the probability that x is less than 10, or the probability that x is equal to 0 or 1. Okay, so the probability that x is equal to 3, well, we know that the probability function for this is equal to n choose k of p to the k times 1 minus p to the n minus k. So the chance that x will be 3 is 8 choose 3 times 0.25 to the 3 times 0.75, which is 1 minus 0.25 to the 5. So this should be equal to 8 choose 3 times 0.25 cubed times 0.75 to the 5. So this is around equal to 0.208. Okay, next, the probability that x is less than 10. Well, we know to solve this that this is equal to 1 minus the probability that x is greater or equal to... Actually, wait, hold on. The number of trials is 8, so we can actually never have 10 successes. So the variable will always be less than 10, so that's just equal to 1. Finally, the probability that the variable will be 0 or 1 is, of course, 8 choose 0 times 0.25 to the 0 times 0.75 to the 8 plus 8 choose 1 times 0.75 to the 1, 0.25 to the 1 times 0.75 to the 7. So this is equal to 0.75 to the 7 times 0.75 plus 8 times 0.25. Because this is, we can group this as 0.75 to the 7 times 0.75 plus 8 times 0.25, which is equal to 0.367. So that should be our answer. What? Okay, apparently it's not. Have I read this wrong? X is B 8 0.25. Probability X is 0 or 1. That's weird. So it should be 8 choose 0 times 0.25 to the power of 0 times 0.75 to the power of 8 plus 8 choose 1, which is 8. What? 8 choose 0 times 0.25 to the 0 times 0.75 to the 8. The probability of it only being 0 is 1, but the book's got it wrong because it asks for the probability of 0 or 1, which is actually this value over here. So this is the correct value. Okay, on to the next question. And the next question is, given that X is a binomial distribution with number of trials 5, probability of success 0.5. So first of all, show that the probability of X is equal to 5 is equal to 1 over 32. Next, construct a probability distribution table. Next, find e to the x. Next, find the variance of x. And finally, find the mode. Okay. So show that the probability that x equals 5. So the probability that x is equal to 5 is equal to 5 choose 5 times 0.5 to the 0 times 0.5 to the 5, which is equal to 1 times 0.5 to the 5, which is equal to just 1 over 2 to the 5. It's equal to 1 over 32. So construct a probability distribution table. Well, we have x, and then we have the probability of x equals x. So for 0, we also have 1 over 32. Because it's a binomial, the probabilities are mirrored. Actually, well, no, it's only because we have a probability of 0.5 here. So 1, 2, 3, 4. So for 1, this is 5 choose 1 times 0.5 to the 5. So it's just more or less 5 over 32, 10 over 32, 10 over 32, 5 over 32, and 1 over 32. Next, find what we expect, and this should simply be 2.5. Since it is evenly distributed here, so our expectation should just be the middle at 2.5. What? How is it? Oh wait, that's the wrong question, isn't it? Yeah, it is. Okay, I was gonna get slightly annoyed. Okay, 2.5. Find the variance. And so the variance is equal to, well, we need sum of the squares, but we can use the cheat that the variance is equal to np times 1 minus p equal to 5 times 0.5 times 0.5 So the variance is equal to 5 times 0.25 is equal to 1.25. And finally, find the mode. Well, if we're looking at our table here, we actually have two modes. It's bimodal, since both 2 and 3 have an equal probability. So the modes are 2 and 3. Nice. Okay, and then for the final question, we have in a French course, students complete 12 tests in a semester. The probability that a student passes is 2/3. So find the expected number of quizzes a student will fail. And next, find the probability that a student will fail more than half of the quizzes. And finally, find the most likely number of quizzes a student will pass. So find the expected number of quizzes a student will fail. Well, this is simply 12 times, the chance of success is 2/3, so therefore the chance of failure is 1/3, which is equal to 4. So we expect them to fail 4 quizzes. Next, find the probability that the student will fail more than half of their quizzes. So we actually need to add up quite a few values. This is going to be 12 choose 7 times 2/3 to the, no, 12 choose 5, 5 times 2/3 to the 5 times 1/3 to the 7 plus 12 choose 4 times 2/3 to the 4 times 1/3 to the 8 plus 12 choose 3 times 2/3 to the 3 times 1/3 to the 9 plus 12 choose 2 times 2/3 to the 2 times 1/3 to the 10 plus 12 choose 1 times 2/3 to the times 1/3 to the 11 plus 12 choose 0 times 1/3 to the 12. So we can simplify this. This is equal to 1/3 to the 7 times 12 choose 5 times 2/3 to the 5. So this is equal to 12 choose 5, 792 times, actually I'm just going to calculate all of these in decimals already. So this is 12 choose 5 times 2/5 to the power, 2/3 to the power of 5. So this is around 104.3 plus 12 choose 4 times 2/3 to the 4 times 1/3, which is equal to 32.6 plus 12 choose 3 times 2/3 cubed times 1/3 squared, which is equal to 7.2 plus 12 choose 2 times 2/3 squared times 1/3 to the 3. This is 1.1, and then we have to add 12 times 2/3 times 1/3 to the 4, which is 0.1, and then plus insignificant number 12 1/3 to the 12. No, sorry, 1/3 to the 5, which is 0.004. So if we add all of this up, we get that the probability is 104.3 plus 32.6 plus 7.2 plus 1.1 plus 0.1 plus 0.004. And all of this times 1/3 raised to the power of 7. So oh, okay, so oops. I didn't read this correctly. Apparently it says that the probability that they will pass more than half of their quizzes, but since we've done all this calculation, which results in a probability of 0.066, we can simply add the chance that they will only pass half of their quizzes to it in order to calculate the real value. So 2/3 to the 6 times 1/3 to the 6 is equal to, so it's this plus 12 choose 6 times 2/3 to the 6 times 1/3 to the 6. And so we end up with a probability of 0.7, I mean in total, we add up with a probability of 0.177. And so if we subtract 1 from this to get the probability that they will pass, we get 0.8223 as our answer. So this is the probability that the student would pass more than half the quizzes. Finally, find the most likely number of quizzes a student will pass. Well, if this was a decimal, we would have to maybe find the true mode. But since the expectation is an integer, the expectation of the number of quizzes a student will fail is an integer, we can simply subtract 12 minus 4 to give us 8. So that's the answer. We expect them to pass 8 quizzes. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.